Hi guys! So, not really much new to say to start this off. We're still talking about factoring, still talking about factoring out a GCF before you do anything. Still want to make sure everybody's comfortable with that, with all of this. Specifically what we're going to be talking about today is, I guess, factoring for term polynomials with a GCF. So these are the kinds of things that are going to require factoring by grouping. So it should be pretty short today. So this is what I'm talking about, right? When you see something, hold on, I'm getting my calculator out. Ugh. Polynomials with four terms are usually the ones that you're able to factor by grouping. So, just clearing my calculator. Jesus. Okay, now we're actually ready. So four-term polynomials, as I was saying, are the ones that require factoring by grouping. But as you've been saying for days at this point, you'll always need to remember to factor out a GCF first if you can. So, 224, 128, 168, and 96. Are all of those numbers divisible by the same thing? Well, they're all even, so we can at least start dividing by 2. So what are all of those things? 224 divided by 2 is 112. 128 divided by 2 is 64. 168 divided by 2 is, let me move this, 84. And 96 divided by 2 is 48. All right, these are all even again, so we can divide by 2 again. And 112 divided by 2 is 56. 64 divided by 2, I know that's 32. 84 divided by 2 is 42. And 48 divided by 2, we know that's 24. They're all even again, so we can keep going and divide by 2. 56 divided by 2 is 28. 32 divided by 2 is 16. 42 divided by 2 is 21. And 24 divided by 2 is 12. So, they're not all even this time, so we can't keep going and divide by 2. 3 is not going to work for every single one. 4 is not going to work for every single one. 5, 6, 7, 8. No, I don't think there's anything else that we can do to keep this going. So, our GCF in terms of the coefficient is just going to be the product of all of these numbers that we divided by. So 2 times 2 times 2 is 8. And they don't have any variables in common, so our GCF is just 8. And these are all the coefficients that you're left with. So 28n cubed plus 16n squared plus 21n plus 12. Now we're going to factor by grouping. So we haven't talked about that in a while. When you factor by grouping, you're taking all four terms and you're breaking them up into groups of 2. So one group of 2 and one group of 2. And you're factoring a GCF out of each. So 28 and 16, what is the GCF of those coefficients? 2 would work, but 4 also works. And I think 4 is going to be it. So 4... They do both have a variable, n cubed versus n squared. The smaller of the two is n squared, so this is 4n squared. What are you left with? 7n plus 4. Now we move to the 21 and the 12. They're both divisible by 3, so positive 3. And then again, you're left with 7n plus 4. In order for grouping to work, you do need to be left with the exact same binomial twice when you factor the GCF out of both parts. So, 7n plus 4 is going to be one of our binomials, and then 4n squared plus 3, just kind of smashing those two together, is our other binomial. And don't forget, guys, if you took out a GCF, you have to bring it in the front, bring it along for the ride. So don't forget about that 8. And there's your answer. And like I said, I believe I said this at the meet session, if anybody went to that. If you decide to check your answer, when you're checking your answer, I would suggest going backwards in terms of multiplying things out, foiling things out. Since you found these binomials last, foiling these back out would be the first thing you would do when you check your answer, and then distributing the GCF back in. And as always, you should get the exact same polynomial that you started with. All right? If I didn't already say this is going to be pretty short because I believe this is actually the last example that I have here. Pretty quick today. So, 28, 24, 35, and 30. Are all of those divisible by the same thing? Well, they're not all even, so 2 isn't going to work. These aren't all divisible by 3. They're not all divisible by 4, not by 5, not by 6. Not by 7, not by 8. I don't think there's anything that's going to work, so I don't think we have a GCF here this time. So we're just going to move into grouping like how we normally do. 28 and 24, what are both of those divisible by? They're divisible by 4, again. So this is once again going to be 4n squared, 4n squared as your GCF for that first group. And what are you left with? 7n plus 6. Now, because that leading coefficient here is negative this time, negative 35, we are going to want to take out a negative as part of our GCF. And then same question, what are 35 and 30 both divisible by? They're both divisible by 5. So our GCF is going to be negative 5. They don't have a variable in common, so it's just negative 5. And then you do have to worry about the sign change when you're doing the division. Negative 35 divided by negative 5 is positive 7. So this is positive 7n. And then negative 30 divided by negative 5 is positive 6. And you need that negative in order for you to get the exact same binomial twice, just like we did last time. So 7n plus 6 times 4n squared minus 5. And as I've said a million times, the order of the parentheses themselves does not matter. If you wanted to do 4n squared minus 5 and then 7n plus 6, that's absolutely fine. All right? So, yeah, that's going to be it for your lesson today. All right, I hope everybody's still doing well. We're about a week in officially at this point of online learning, and I have to say it's going pretty well. I hope you guys I hope you agree with me on all that. All right, talk to you guys soon.